anti-radiation guided missile, Aargm, a joint co-development program between the US and Italy, will transform from suppression of enemy air defenses to destruction. Aargm takes advantage of proven propulsion and warhead technology from the Aargm F-18 HARM system, while blending advanced sensors into an all-new guidance section. The rocket motor and the 145-pound blast frag warhead will be retained in the baseline Aargm modification. Aargm brings a new digital anti-radiation homing seeker with increased accuracy and sensitivity. A new millimeter wave radar terminal seeker will significantly increase the lethality of the missile by providing the capability to track the intended target regardless of whether its radar is emitting or not. The control section is modified by adding INS GPS and worldwide digital terrain elevation data to fuse with the seeker information to generate a geolocation of the intended target. The most revolutionary additions will be an integrated broadcast service receiver and a weapon impact assessment message transmitter. This combination of new sensors and navigation capability, with the addition of net-centric operations, will bring the commanders and the warfighter a new, much-needed strike capability. In this scenario, the F-18 is assigned a seed mission in support of a planned strike against a known target. The aircraft is configured with 3 Aargms, 2 of which are assigned specific pre-planned targets, with the remaining Aargm for contingency targets as required. The aircrew has planned the mission to include the known target descriptions and their locations. All 3 missiles can be loaded with the same missions, thus allowing the pilot to select any or all missiles for this mission or any assigned missions received en route. Airborne, the pilot selects the target of opportunity mode and the cockpit display switches to TOO. A new target radar mission is seen by the Integrated Broadcast Service, or IBS. Aargm has determined target location through the use of a GPS INS and DTED. Aargm is launched. The highly sensitive ARH seeker tracks the radar emissions. The ARH tracks multiple emissions en route to the target and uses these to refine the target ID and location. As the missile continues into the target area, the millimeter wave radar begins an area search. After the initial search, the radar revisits those targets of interest falling within the area of regard and outside any impact avoidance zones. The area of regard, impact avoidance zone, or missile impact zone can all be loaded into Aargm before flight or via upfront display prior to missile launch. With the addition of GPS INS, Aargm will ensure that the missile impacts within the specified areas and avoids unintended locations. As Aargm closes the target, the millimeter wave radar determines the radar contact that best satisfies the target description based on return, emissions, and geographic location. Prior to impact, the WI transmitter will transmit estimated impact information. This data, received by satellite receivers, will be used in the determination of potential bomb hit assessment. Another target off the air. Aargm will take advantage of the launch platform's targeting capability. As land or sea targets are identified and located with the aircraft radar, or FLIR, target coordinates will be downloaded directly into the missile, allowing the Aargm to be launched to GPS coordinates in a time-critical strike for land targets or in a war at sea scenario. Aargm will acquire enemy ships' radar emissions as it closes on the target, leading to a terminal track with the millimeter wave radar, or, in the case of a land target, transition to millimeter wave terminal tracking. Aargm brings new capabilities to the warfighter: high-speed time-critical strike, improved countermeasures capability, and destruction of enemy air defenses. Coming soon to a theater near you.